Number 17. An automobile engine can produce 200 Newton meters of torque. Calculate the angular acceleration produced if 95% of this torque is applied to the drive shaft, axle, and rear wheels of a car, given the following information. All right, so first thing before I continue reading, here's one wheel. Now remember, there are two wheels on the, there are two rear wheels, right? So this is just one of them. Okay, that'll be important though in our calculation that we have to remember that there really are two wheels. So this details the wheel pretty well, and there will be three parts to the wheel as far as what they tell us in the second half. And then this picture up here will then represent, here now are the wheels, okay, in black. And the axle is then something that connects the two wheels together. And basically it connects not only the wheels to one another, but it also then connects to the drive shaft, which then the drive shaft connects to the engine, but we don't need to worry about that. All right, so, but this is the basic picture. So you're going to have two wheels. Okay, two wheels. You're going to have one axle and one drive shaft. Okay, so now knowing that, let's try to tackle the problem. So it tells us that a automobile engine is producing 200 Newton meters of torque, and we are asked to find angular acceleration. So you should be thinking to yourself, how are those two variables connected? They're connected via this formula over here on the right-hand side. So basically the sum of the torques, okay, will equal the moment of inertia for the whole system multiplied by then the angular acceleration. So to find the angular acceleration, it's simply the sum of the torques divided by the moment of inertia for the entire system. Now, the problem tells us the torque that is being produced, though only 95% of that torque is going to be actually used to provide energy to the drive shaft, axle, and rear wheels. That being the case, the value or the torque that's important in this problem will be 200 newtons multiplied by 0.95, because we need to find 95% of the total torque, right? Because that's the torque that's actually being supplied to the drive shaft, and therefore then to the axle, and then therefore to both wheels. Okay? So what I can now do, okay, so that takes care of the numerator. Now the denominator, okay, to find the total moment of inertia, if you look over here on the right-hand side, basically what they're saying is that the total moment of inertia is equal to the moments of each individual piece, however many pieces there are rotating in the problem. That should be a 3. Okay? So that being said, we need to think about what are the total number of pieces there are. Well, essentially they told us in this information down here, they told that there are 5 pieces. Okay? One piece will be, as they said, the wheel. Okay? That's the part here in yellow. Then they said that the tire also has a wall. That's the part in red. Then they said that the tread of each tire acts like a hoop or whatever. That's the part in black. Okay, that's for each wheel. Remember, there are 2 wheels though. Then it tells us that the axle acts like a rod. So here's now my axle. And then they told us the drive shaft. They told us information about the drive shaft. So essentially we have in total, we have 3 pieces for each wheel. However, there are 2 wheels. So really there are 6, right, in total there. And then there is 1 axle and 1 drive shaft. So that makes basically a total of 8. Okay. Now we understand though that the wheels are symmetric, and therefore whatever moment of inertia I calculate, let's say for the yellow component here, which is the wheel, that I can basically just multiply by 2. Right? Because if I find it for one wheel and the other wheel is identical, I can just multiply by 2. So let's try to now set this up. Okay, so basically it's going to be alpha, specifically for this problem, it's going to be the torque multiplied then by 95%, or 0.95. And that then will be divided by now the moment of inertias. So the inertia of the wheel, that's the first component. And we'll say that whole thing could be multiplied by 2. Plus then 2 times then the walls, which I told you were in red. So there are 2 tires, so therefore 2 walls. So I'll say the moment of inertia of the walls, WA. Then plus 2 times the tread, Okay, so that's the moment of inertia of the tread. Then plus now, not 2 anymore, because now we're talking about the axle. So the axle, there's only one of them, right? So plus then we're not going to multiply this by 2, plus then I, the moment of inertia of the axle. Last but not least, then plus the moment of inertia for the drive shaft. And now here we have our formula, okay? So let's expand on this now. I'm going to need some more space. So this is basically now just going to be equal to, so again, it's just the torque times 0.95. Now the moment of inertia for the wheel, they tell us the wheel acts like a 15 kilogram disc, and it's a solid disc, okay? So therefore I'm going to be thinking about this picture and this formula for the moment of inertia for that wheel. And these pictures can be found in your textbook, page 359. So what now we can do is take now 2, multiply them by the formula for the moment of inertia for the wheel. That's going to be then the mass of the wheel multiplied by the radius of the wheel squared, all divided by 2. Okay, plus then 2 times now the moment of inertia for the wall. And they told us in the problem, it says the wall of each tire act like a 2 kilogram annular ring. So here's the formula and the picture for the annular ring. Okay, so that's basically now going to be the mass of the wall, all over 2, times then the inner radius of that wall, not multiplied, but added to then, you're going to have the outer radius of that wall squared. Okay, so here's the inner, it's 0.18 as they told us, and the outer is 0.32. So that takes care of that. Then the second piece here is now the moment of inertia for the tread. Now, again, we have to multiply that by 2. So going back to the problem, it says that the tread acts like a hoop. So here's now the picture for the hoop and the corresponding formula. So basically now this is going to be 2 times the mass of the tread multiplied by the radius of the tread squared. Okay. Then, isn't this fun? Then we have now the axle. Remember, there's only one axle, so we're not multiplying it by 2. And now it says that the axle acts like a rod. All right, and you might notice that there's several pictures in the book, but the way the tires if the tires are rotating, this way, the rod is also rotating this way. So it's rotating about a center axis here. Okay, so this picture is what it's going to be. And solving now, or not solving, but plugging in the formula there, it's now going to be the mass. And actually, you know what? Let me just do this quick. Let me just move this whole thing on over. 1 second, guys. Trying to just give myself a little more space. So now this is going to be the mass of the axle multiplied by the radius of that axle squared, all over 2. Last but not least, then the drive shaft, which is the same thing. It's a rod, right, rotating about a center axis. So it's going to be the mass of the drive shaft multiplied by the radius of the drive shaft squared, all divided by 2. So here is our formula. It's a beautiful thing. Now we get to plug in the values. So alpha now, okay, will be equal to the torque, which they told us was 200, multiplied by 0.95. Now it's just mechanical from here, meaning you just got to plug in the values. Then divided now by, I'm going to also do some canceling here in terms of some of these values, right? We notice that these 2's will cancel, right? What else will happen here? These 2's will cancel. And that's basically all that I notice is going to cancel easily here. So now it's going to be the mass of the wheel, they told us, was 15 kilograms. So 15, I'm not going to write the 0.0 because I need the space. Multiplied then by our radius, which was 0.18, and that's squared. Plus then the mass of the wall, they told us was 2 kilograms. So multiplied then by the inner diameter, the inner radius, which was 0.18 squared, plus then the outer radius, that is 0.32 squared, then plus 2 times now the mass of the tread, 10 kilograms, so 2 times 10, multiplied then by the radius, which they told us was 0.33, and that's squared, plus then the mass of the axle, which is up here, 14 kilograms. So 14 kilograms multiplied by the radius, which was, they gave it to us in centimeters, got to have it in meters, so 0.02 squared, all divided by 2. And then plus the drive shaft, finally, I'm going cross-eyed. The mass of the drive shaft is going to be 30 kilograms. The radius, they gave it to in centimeters, but I converted it into meters, so 0.032. And that is squared, all then divided by 2. Oh my God. All right. Finally, now we get to plug it into the calculator. So I'm just going to do the denominator first. I'm going to solve for the total moment of inertia. So 15 times 0.18 squared plus 2 times 0.18 squared plus 0.32 squared. And then plus now 2 times 10 times 0.33 squared plus 14 over 2 is just 7. I'm just going to write 7 times 0.02 squared plus then 30 over 2 is 15. So 15 times 0.032 squared. Hope I did not make a mistake. And I get a value of about 2.95. So this whole thing comes out in the denominator to be about 2.95. And now what I'm going to do is I'm going to take the 200 multiplied by 0.95 and then divide it by that denominator value. So I get a value of approximately now 64.4. Okay, radians per second squared. And that would be the angular acceleration. So guys, thank you so very much for tuning in. Please remember to subscribe if this problem helped. And tell your friends also, that'd be a way you'd be able to actually help us and help our channel grow, and we would be very appreciative of that. We appreciate your viewership. We really do hope that we are providing value to you, and also that we're able to help you through your class. Thank you very much.